Hi everyone, this is Alice Fisher from the Rice University School of Mathematics project, and today I'm going to be talking about integrating the TI Nspire CX handheld calculator technology into Algebra 1. So what I'm going to be talking about in this video is first an overview of the handheld technology, and then focusing on three of the apps: the calculator, graphing, and lists and spreadsheet app. So when you take a look at the TI Nspire CX keypad, there is an area at the top that looks significantly different from, say, the TI-84. So if we go through the buttons, you can see that one of the significant differences is the touchpad, which is not a touch screen, but allows you to move the cursor while touching the pad with your fingers. And in order to select or click on an item on the screen, you can press the middle button. So the button that I am a big fan of is the escape button, and it basically undoes the things that you have done that you're not really happy with. You can just undo by escape. The other button, which is very important, is the menu button, and when you press on it, depending on where you are, it gives you a list of options for that particular page. So we'll go over these other features, but I did want to provide an overview of the keypad. One of the things about the Nspire family of handhelds is that you can work with documents that you can save and share and add pages to. So we're going to take a look at one of the prepared documents that I had for this presentation. So now where we are is I'm using the teacher software to show this particular TNS file. And so welcome again to the TI Nspire CX. And notice that this is a document that contains multiple pages. So let's go ahead and add a calculator page, and then a graphs page, and then a lists and spreadsheet page. So in order to add any type of page, what we're going to do is press Control and then Dock, and you can see that above the Dock button you see a plus page. And let's add a calculator page, which you can get to with a keypad by either scrolling up or down with the up and down arrows or pressing the number 1. And you can see that this is just an app which allows you to perform operations with numbers and some other things that we're going to show in a couple minutes. Now to add a graphs page, we're going to do the same thing. Control Dock, and we can see graphs is option 2. And in this case, we have, instead of y equals that we normally saw in TI-84s, we see in function notation f2 of x. And you can click up or down to see what other functions have been stored in memory. So we can see that f1 of x is 3x plus 3. Okay, and if I want to add another function, I can press down to get to f2 of x, and let's say we can enter in another linear function, negative 4x minus 1. Notice that minus is different from the negative button, negative numbers. And we have 2 functions. If you wanted to add another function, you would press tab and enter a function in for f3 of x. Now let's go ahead and add a list and spreadsheet page. So I'll press Control, Dock, which is plus page, and add the number 4. And you can see it looks like a spreadsheet, and in this first row, this is where you give it these list of values a name, say time, So what we're going to do is take a look at some problems from the released STAAR exam for Algebra 1 from 2016. So let's take a look at this problem. The graph of 0.5x minus 2y equals 3 is shown on the grid. Which ordered pair is in the solution set of 0.5x minus 2y greater than or equal to 3? At this point, I do want to stress that these techniques are used to confirm answers, that you've used many strategies throughout the year in Algebra 1 to approach and solve these problems, and the calculator is just a tool to check your work. So suppose that I did the work and I got that the answer was 2, 1. So what I'm going to do here is enter in x equal 2 and y equals 1. So let's add a calculator page. All right, so x equals 2. I'll go ahead and store 2 in for x, the variable. So I see store is in blue, so I'll press Control var, and I will store that as x. And then I'm going to store the value of 1 for y. Now I have the expression 0.5x minus 2y. So I'll enter in 0.5x minus 2y. And I can see that the answer, that the expression, if you substitute the values of 2 for x and 1 for y, is equal to -1. And I clearly know that -1 is not greater than or equal to 3. That is a false statement, so it cannot be choice B. Well, let's go ahead and take a look at C, which is x equals 2, y equals -1. So I'm going to go ahead and store -1 in for y. So let's go ahead and enter in -1, store, and then y. And then if I enter y, then I'll get the value of -1. So let's go ahead and add 0.5x. Actually, what I can do is just copy and paste by pressing the up button till I get to the expression, and then that copies and pastes. And then I'm going to actually add a greater than or equal. And you can see these comparison operators right above the equal sign. So I'll press Control equal, get greater than or equal to the number 3, and I get the answer true. So that is a true statement. So that would be the answer, option letter C. Now, let's take a look at the next problem, which is number 27. If f of x equals 6, parentheses 1 minus x, close parentheses, what is the value of f of -8? And so what I'm going to do is store x, -8 for x, and then enter in the expression 6, 1 minus x. So let's go ahead and store -8 in for x. Then I'll go ahead and enter the values, 6, or the expression 6, 1 minus x, and then I get the answer, 54. Okay. So we're going to go ahead and now explore the Graphs app. If we take a look at this problem, number 6 from the Algebra 1 EOC, which expression is equivalent to 2x squared plus 7x plus 4? So we want to know for which of these other expressions here are for any given value of x, the y values will always be equal. So we're going to enter in 2x squared plus 7x plus 4 into our graphing page. So let's go ahead and do that, which is here. So let's add a graph, Control plus, and then 2. And I'm going to enter in 2x squared plus 7x plus 4. Okay, and I can see it's a quadratic function. So now I press tab to enter in the first, let's say, I think it's letter, say, letter H, 2x plus 1, x plus 4. So I'll enter in parentheses 2x plus 1, x plus 4, and I press enter. And I can see that the graphs of these do not match. Now I want to take a look at the table just to get confirmation that these are not equivalent expressions. So go to menu, and that gives you a list of options, and we want the table. We want to be able to see the table. So this actually splits the screen so that you can see the graph on the left hand side and the table on the right hand side. And as you scroll up and down for a given x, you can see the y values are not equal. We can go ahead and remove the table by pressing menu, 7 for table, and then 2 for remove table, and then you get only the graph. Now if we press tab, let's go ahead and press the up arrow, and let's try option G, which was 2x plus 1, x minus 4. So I'm going to go ahead and put delete x minus 4, enter. And again, I can see that the graphs are definitely not the same, and therefore these are not equivalent. And if you try the last one, the graphs do not match as well, and you want to always double check it with the table to see that the y values are equal no matter what the x values are, and the answer to this would be letter J. All right, let's go ahead and take a look at this problem where you're actually looking for the unique value of x, which makes this equation true. And so what we want to see is for any given value of x here, there's a y value for this expression. If you evaluate it, substitute in a number for x and you get a y value. And the same thing for this expression. So at which value of x are the y values equal? So let's go ahead and graph the left side and then the right side and take a look at this a little more closely. So we're going to create another graphs page. Now at this point, I want to show you how to create a new document, not just adding a new page. So let's go ahead and go home. And home is a great place to go if you're not sure what to do at the very beginning. I do want to create a new document. Don't save unless your teacher wants you to save. So let's press enter. And I'm going to add a graphs page. Now, notice how we start at 1.1. This is an entirely new document, and therefore we're starting back at f1 of x. So I'm going to enter in negative 5x minus parentheses negative 7 minus 4x close parentheses. Enter. Okay, so I see that it is a linear function. Now, let's enter in the second expression, the expression on the right-hand side. So I'll press tab, and I enter in negative 2, parentheses, 3x minus 4. Okay, so actually I want to show, I think this is originally what it looks like. Okay, so now at this point, this represents the expression on the right hand side. So for every value of x, if you substitute in a value, then you get a y value. So for example, say at x equals 1, here the y value is about 2. For x equals 1, it looks like the y value is about 6, a little above 6. So the question is at what x value are the y values going to be the same? And so if we took a look at this graph, it looks like for a particular x value, the y value is going to be the same where the lines intersect. So I want to look for the intersection point. I can't quite see it. So I'm going to go to Window, and I'm going to press Window Zoom, number 4. Oops, let's try that again. 4. And I want to select Windows Settings because that gives me the most control. Now, I can't quite see right where that point of intersection is. So I know I need to make my window a little bit taller. So instead of a little bit more than 6, I'll go ahead and enter in 20 just to make sure I get that point of intersection. And there it is. Now I want to find exactly where that point is. I can estimate, I can see x is between 0 and 1 and closer to 0. But if you go to menu, let's analyze this graph. There's lots of options. I want to find the point of intersection, which is the number 4. The lower bound, you're going to have to use a touchpad and just kind of get that vertical line to the left of the intersection point, and then drag your finger over to the right of the intersection point, and then you can see that the intersection point is 0.2 comma 6.8. So let's take a look at the problem again. So when x is equal to 0.2 for all these instances here, you substitute in and you would get 6.8 equals 6.8, which is a true statement, so the answer would be 1/5. Okay, list and spreadsheet app. So what is a y-intercept of the line graphed on the grid? -2, 7, and then the 0.61. So I'm going to go ahead and write down on an actual sheet of paper this problem to kind of set it up. Okay, so here it is. Now I know this is the x value and this is a y value, x1, y1, and I can call this x2, comma y2. Okay, so if we create a table of values for these 2 points, this is x and y. I know for the first ordered pair we have -2, 7, and for the second ordered pair we have 6, 1. This looks like a table. It actually also looks like 2 different lists. So what we're going to do is we're going to take a look at the list and spreadsheet app. So to add a page, press Control plus page and choose number 4. All right, so I'm going to go ahead and add x val for values. And for the B column, I'll call it y vals. Okay. Now we've got 2 numbers in the x column, -2 and 6. And we've got 2 numbers in the y column, 7, 1. All right. So if you're familiar with the TI-84, what we basically have is 2 points. So on the TI Nspire, another app that you can use is the data and statistics page, which is number 5. Okay, so I'm going to click on the horizontal axis and select x values, and I know we have a -2 and a +6. Now I'm going to click on add to variable for the vertical axis, and I'll select y value. I'm going to go ahead and go back to 1.2, and we're going to select menu, and we want to find the line of best fit, which is statistics. We're going to calculate it, which is number 1, and we know it's a linear function, so we're going to press the number 3. Now in this case, you press the right arrow to get the options, the names of the lists that you have in your spreadsheet, and I want x vals. Then I press down, press right, and then I scroll down to get my y val. It's going to save the equation in F3, and then I just hit down, down, down. It's going to give me my results in the C column, and I press enter. And here we are. So our slope, which is represented by m, is -0.75, and our y-intercept is b. Okay. So if we want to show the line on our data and statistics page, what we can do is press the menu button, analyze, number 6 for regression, and 1 for linear in the form mx plus b. And we have, again, the slope as -0.75 and the y-intercept as 5.5. So for our problem originally, we wanted to know what is the y-intercept. So the y-intercept in this case is 5.5. Okay, so I just want to summarize again the advantages of the TI Nspire. It is similar to a Windows or Mac interface, since as you've seen, it uses drop-down menus, documents, point and click, and can have multiple windows and pages. So if you're longtime TI-84 users, you can feel a bit frustrated during the transition to an Nspire, but for new users and in particular students, it's much easier to get started with a TI Nspire compared to a TI-84. We've gone through the different apps, and if you have any questions, you can email me at alicefisher100@gmail.com. I hope you enjoyed the presentation.